All right, so we have 5 ways to prove triangles congruence. Today's lesson is on section 5.4, get that just right, which is the SSS Triangle Congruence. So write this in your notes like that. So as I said previously and already, but we have 5 ways to prove triangles congruence. All right, so let's go ahead and give those 5 ways. All right, so we got number 1. The first way was ASA. And it said 2 angles in the included side. And then yesterday, we added to it the SAS. That's 2 sides in the included angle. And today, as you can see, we're adding to it again, and we're going side, side, side. Okay, 3 sides of one triangle congruent to 3 sides of another. So, let's see, kind of like, you know, a little dialogue here is happening. The side, side, side says, if 3 sides of one triangle are congruent to 3 sides of another triangle. This is on page 256, by the way. The theorem, I'm writing it in. Of another triangle, then, the lovely if-then. Conditional statements in geometry, if-then. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. There's the theorem. Okay, so that's 3. We've got 5 total. Let's go ahead and give you the other 2. Okay? Just so you have them. Number 4 is AAS. Okay, so it's AAS as it works its way around a triangle, angle, angle, side. Okay, so it's not the included like we did yesterday with the 2 sides and the included angle with the closet back there, right? It's angle, angle, side. We'll talk about that tomorrow. And then the last one's kind of a special case. It is called HL, and it only works for right triangles. So it's a special case. Okay? So there's our 5 ways to prove triangles congruent. ASA, SAS, SSS, AAS, HL. Mason. This is not a way to prove triangles congruent. I know you're bummed out about that. No, don't go home and tell your mom and dad I'm cussing geometry. Chase, I don't want you being offended. I'm writing a cuss word on the board. I'll mark it up. Cover it up, Jadelyn. But truly, that is not a way to prove triangles congruent. Lainey, so don't think, I'm going to put it on a quiz. It's going to be so funny. No.
What if we all did?
No.
I was just asking.
It's 5 ways. ASS. No. Hope. It is not a way to prove triangles congruent. And, likewise, neither is this. Don't try it. Just change the order. That is also not a way to prove triangles congruent. Okay? No, seriously. It isn't. Okay? It doesn't work. You could actually try it, but it doesn't work.
Try it. Let's see. Okay?
It just doesn't work. I don't want to do it now. All right. And so there's also another way that doesn't work. Remember we talked about the 60-degree angle triangle? We have AAA. That doesn't work either. Does that make sense? And so we've got 5 ways that do work and basically 2 ways that don't. We don't need 6 parts anymore. We only need the correct 3 parts. Okay? All right, so today, though, we're going to focus on the side. So we're going to focus on this one. All right, any questions? Okay, so turn in your book to page 263. I'm going to go ahead and give you the problems that we're going to do on the homework. And we're going to do like 5 problems together. 12, 14, 15, 16 through 21, 23, and 27. And just so you all are aware, today we're doing this one. Tomorrow we're doing AAS. Monday we're doing HL. Tuesday then we're reviewing. And when we come back for virtual class in geometry, we're taking a quiz over these 5 days.
Wait, when we go back to virtual?
When we come back from Thanksgiving, we're going to do a quiz virtually, like we did before.
Wait,
last
so
week.
We're out for 2 weeks after though, aren't
We're not out, it's just virtual. I mean, we still keep going.
we? Well, yeah, I understand that, but you're saying when we get back.
When we get back to school, we're still doing
Oh,
school.
okay. Well, I thought you meant like when we actually come back into school.
Physically?
Yeah.
No. When we're
that's
back
gonna be
virtually,
a long
we're going to take a quiz. And it'll be over the 5 ways. Okay? So, all right. That lays out the plan. All right. So here are the problems that we're going to do for our homework. We're going to do, like I said, 5 of these together. So have your book open. Let's start with number 12. Number 12. All right. It says, all right, Bo, help me out here. Would you please? We've got a triangle over here. What's this triangle? What's that length up there? 8. And what's this one over here? Okay, and then we've got a triangle. Something like that. I don't know. What's this one up here? And then what's this one? Okay, so the directions say, prove that the triangles are congruent or explain why this is not possible. Well, when I look at this, if I'm trying to use, which I am, I'm trying to use the side. That means I want all 3 sides of one triangle congruent to all 3 sides of another. Well, if I twist and rotate these, 8's going to equal 8. Everyone okay with that? But 12 doesn't equal 10. But since we don't know what this one is, could this possibly be a 12? Now, I wrote it like that so it kind of looks like it could be, but it's not really. Okay? And then, could this possibly be a 10? If that were the case, if I had my ruler out and I were measuring, and this were 12 and this were 10, would these be congruent? Yeah. I would say yes. But if this were 10.1 and this were 11.9, then would they be congruent? No. So the answer is actually, you can really tell. It's possible. Right? Let me read to you exactly what the book says is the answer. But do you understand the possibilities? All right, the book says this. Possibly congruent, depending on the length of the unlabeled sides. That's the answer. Possibly. Just depends. Okay. All right, that's 12. Let's take a look at 14. Okay, so we've got a triangle here. It looks like a isosceles triangle. That's 25, I believe. 25. Then we have another isosceles triangle. Isosceles means that there's 2 sides which are congruent. Well, what's the base of this one over here? What's this base down here? And what's the base over here?
15.
Okay, so if I'm trying to show that these triangles are congruent, well, we don't have any angle measures, so again, I have to use the side, 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 right? I know I've got 3 of them, but I haven't used these yet. I'm only using the side, side, side. Okay, so 25 would be equal to 25, and then 25 would be equal to 25. So that's good so far. The only one I don't know is this side right here. Nicholas, what do you think we could do to find the value of x to see if these are congruent? What do you think?
Basically, you put it in an arbitrary form.
I don't like formula, I like equation better,
Yeah.
but Nicholas is exactly right. We just use our algebra skills and we set up an equation. Because if those are sides are equal, and they would have to be in order to use the side, 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 then that's the equation that we can use. All right, so let's solve this. You can do it at your seats. I'm going to do it up here. Let's solve this equation. I have to undo whatever they're doing to my variable. The first thing I'm going to do is add 21. Now I have 9x, and that's equal to 36. The next thing I'm going to do to solve for x then is divide by 9. And so now I have x equals 4. And so the value of x, which makes these triangles congruent, is x equals 4. If I put 4 in, what's 9 times 4? 36. What's 36 minus 21? 15. Ah, it worked. Got it? Good so far? Michaela, any questions? James? Got it? All right, let's keep going. Let's go to number 15. Number 15. Like I said, I'm going to do 5 of them for you today. 15. Top of the next page. I believe this one's 30 degrees. This one's 60 degrees. Bo, help me out. The top one's still 30 degrees?
Yeah. 15 line. Yeah.
All right, what's the length of this side over here? 14x minus what? 47. And this one? And 9. Okay, so, well, we got an adjustment right off the bat. Are we using side, side, side anymore, Mason? Look at that closely. Does that look like we'd use side, side, side? Since we only have one side? No, I agree. How many ways do we have to prove triangles congruent? We have 3 by now. We have ASA, we have SAS. Which one of those 2, based on what's given, do you think we would use? Because we have an angle, and a side, an angle, and an angle. Which one do you think we'd use? Very good. That's right. We've got to use the ASA. Okay? And so, the angles would have to be congruent. 30 and 30. That makes those. Those are good. Is somebody helping you, Mason, or what? Oh, you did? I couldn't hear you. Not fun. Michaela, did he say that? I seriously didn't hear it. Okay, so now we go to the side, and we set up an equation like we did before. 14x minus 47 is equal to 9. So now we've got that taken care of. And then we go to the last angle, 60 and 15y, and we set up that equation. 60 equals 15y. So we're going to have to solve 2 equations. Oh, no. Nah, not a problem. Not a problem. Okay, Chase, if I'm going to solve this, what would you do first on this equation right here that I'm pointing at? Outstanding. 14x is equal to 56. Chase, keep going. What would we do next? Have to undo whatever they're doing to our variable. We're going to divide by 14, and we end up with x equals 4. Carter, we good? What would we do here to solve for y? Okay. And we end up with same answer. It doesn't happen very often, but it did there. Okay, and so by the ASA theorem, we know when the value of y is 4 and x has a value of 4, that they would be congruent. Right? Does that make sense? Are you getting the hang of it? Okay, we got a kind of a similar type of problem now that we're going to look at, but a little twist, a little different. I call it a little curveball. Okay, a little curveball, Bo, and baseball. See if you can hit it. Let's go to number 19. Please, can you read it off for me?
Triangle ABC, sides of length 19, 25, and 5x minus 2.
Okay, hang on. So we've got three lengths, 19, 25, and 5x minus 2 for number 19. Let me move this to the top of the screen so you guys can all see it. Okay. And then I think it's DEF, right, Elise? All right, and what are the three sides?
Sides of length is 13, x minus 9, and 2x minus 6.
2x minus 6. Okay, so, well, what are we going to do here? What we have to do is determine which ones we can. Is this 13 or is that 25? At least let's try that again. Let's do this.
25, 28, and 4 minus 1.
At least in my mind, I started to say, okay, how are we going to do these equations? And I'm like, wait a minute, this don't look right. We can't do that. All right, so these are our three sides. Now, do we know which side is considered AB and which side is considered BC and which side is considered AC? We don't. We've got all kinds of possibilities, though. And so we have to investigate the possibilities. Well, if I look at this closely, not very difficult to see, that those two sides would have to match up because they both have a length of 25. Jalen, does that make sense? Okay? And so then, would 19 go to 28? No, they're not the same length, so they can't match up. So what would 19 have to be equal to? 4 minus y. So I'm going to go ahead and bring that down here and set up an equation. Don't solve it yet, just hold on. We're going to solve it soon enough. And then the last set would be this side to 28. So 5x minus 2 is equal to 28. Got it? Now, solve for both x and y in both of those equations. All right, so if you don't remember how to do that, just watch me. I'm going to get it done. Subtract 4. Negative y. Take the opposite of both sides. So I end up with y is equal to negative. Over here, I add 2. And I divide by 5. And so there's my solution on 19. X equals 6. Y would equal negative 15. Now, you've got to be careful, especially in geometry. When you've got a negative number, you better make sure it doesn't give you a negative length. If it gives you a negative length, that's no solution. So if I put negative 15 back in, what's 4 minus a negative 15? 19. Positive. So we're good. We just got to be careful that the value doesn't then portray like a negative length for a side. Does that make sense? Okay. Let's do one more. One more, and then we'll turn you loose on the homework. This is number 20. And we're going to have a chance for somebody to get a piece of candy. Number 20. Who read the last one out? Micah, can you read this one? Elise did, right? She struggled. Hey, Micah, let's do a little better.
Triangle ABC, the sides are 8, x minus y, and x plus y.
Keep going.
And the other, triangle DEF is 8, 15.
Alrighty. So there's the scenario this time. Much better, Micah. Much better. Okay, so we know that 8 would match up. Everyone okay with that one? Okay, but what about x minus y? Would that match to 15 or 17? What do you think, Nicholas? Okay, let's do that one first. And then if that's the case, then x plus y goes to 17. So here, watch this, how I do this. X minus y equals 15. I'm going to put it right below. I have 2 variables and 2 unknowns. This is a special type of algebra problem. Maybe towards the end of Algebra 1, you discuss this. Towards the end. Does anybody recall the name of this type of problem? We've got Jolly Ranchers to choose from. Maggie, what do you think? System of equations. Look at Maggie coming through.
Because I don't know how to do them.
Oh, nice. All right, you want red or grape?
Red.
I do not know how old those are, so good luck.
Well,
Don't hurt your teeth. Okay, it is a system of equations. When we have a system of equations, we have 3 ways to solve a system. Those of you that had me in class, we went over all these ways. Each one. We have graphing. Because when you graph, I would graph it over there on that thing over there, you end up with an ordered pair, because that's the solution. And then you would have substitution, where you solve for one variable and you put it into the other one, the equation. And then the best of all is called the elimination method, where you're going to add or subtract the equations and eliminate one of the variables, which is exactly what we're going to do on this equation, on this problem. Okay, so back to here, we are looking at the elimination method. We're going to add these equations going down, and we're going to eliminate the y's because they have opposite signs. So x plus x gives us 2x. Negative y plus y, they eliminate. That's why it's called the elimination method. 15 plus 17 gives us 32. Now I'm going to solve for x. 2x equals 32, and x equals 16. Once I know what the value of x is, I'm going to substitute it back in. Does not matter which one. Substitute it back in and solve for y. Let's put it into the first one. 16 minus y equals 15. Solve for y. I could add y, but it ends up with 1 is equal to y. So I have a solution of 16 and 1. Is everyone okay with that? Everyone okay? Lily, okay? Kylie? The elimination method. All we did was add going down. And eliminated the y's. That make sense? Because they were already opposite signs. I could have eliminated the x, but this was easier. This was a negative 1 and that was a positive 1. Okay, that's a good question. All right, now, here's the problem, though. I asked which one the x plus y matched with and x minus y. Nicholas said here, and then we did that. And so we came up with a solution. However, is there anything that tells us for sure that it has to match that way? No. What if x minus y went to 17 and x plus y went to 15? Could that be a possibility? Most certainly. So guess what we have to do? We have to do another one. X minus y equals 17, and x plus y equals 15. So it's very similar, but we just change the constants. We're going to do elimination method again. Kylie, which one do you think we're going to eliminate? The y, because it's easier. One's negative, one's positive. We have 2x, these eliminate, equals 32. 2x equals 32, and x equals 16. Same value for x, but let's plug it in, see what we get for y. I have 16 minus y equals 17. You see that okay? Now, if I add y and subtract 17, now I have y is equal to negative 1. Ooh, look at that. A little bit different. So you actually have two solutions in your solution set. Could be 16-1, could be 16 and negative 1. And they both work. Does that make sense? And so on those type of problems, 19, the ones that 19 and 20 are on, you just have to match up the sides to see which ones work. Okay? It's almost like a process of elimination. All right, we all good? All right, before I turn you loose, let's talk about the proof. Turn over to page 266. We're not doing the proof. I just want to help you a little bit with it. Okay? So this is the last problem, which is number 27, the proof. Here's the hint. Okay? On the proof, here's the hint. You have to first prove triangles are congruent by the ASA. And then use those triangles, those parts, to prove what you're trying to prove by the SSS. So it's like it's only 5 steps. The proof's only 5 steps, so it's not long, but it's a little different than what we've done to this point. That's why I'm giving you a hint. You're going to prove this first, and then you're going to use the idea CPCTC, and then you're going to have enough to prove that. Got it? Corresponding parts, congruent triangles are congruent? Yep. All right, any questions? You got the plan for the next few days after Thanksgiving? All right, the rest of the time's yours. Let's get to work on the assignment.
Can you let us know